Hello, my name is Jimena Carlos, and I am the project manager for the Natural Language Processing Final, and we are doing the Amazon book reviews. For the first slide, I did a project overview. The team members are the project leader, Jimena, data lead, Gracie, technical lead, Aiden, and writing lead, Christopher. And we are doing the sentiment analysis of Amazon book reviews. This dataset has 3+ million reviews, and it has over 200,000 unique books with usable data for analysis. The sentiment columns can consist of unique review texts, star ratings, 1 through 5, fullness scores, and timestamps. Goals for our NLP sentiment project is number 1, predict star ratings from review text. Number 2, identify what makes reviews helpful to readers. And number 3, uncover patterns between sentiment and book ratings. The Amazon Sentiment Analysis project status. Currently, we have completed documented Amazon book review data set, draft and submit project proposal with problem statement, established team roles and project timeline, and we have begun the starter code for data cleaning and sampling. Progress, we are working through the data cleaning and pre-processing code, which we have all almost completed. We have completed slides for an update on project status in the early stages. We are recording slide presentations right now, performing exploratory data analysis with visualizations, and we will submit the preliminary presentation once we are completed with all of our steps.
Although there are no official numbers available, it's estimated that there are between 30 and 50 million books available for sale on Amazon. These can be audiobooks, books published by small organizations or independent authors, popular books, unpopular books, good books, bad books, that sort of thing. It'd be unreasonable to expect users to manually browse each of these books to find one that they like. As such, there needs to be a way to sort and recommend the books that users will prefer. Therefore, we will use a text analysis system to rank books based on the sentiment of the review and how other users rate that review. If it's successful, personalized book recommendations can be based on a user's review patterns. This project, we have a few questions that need to be answered. The most important one is there a review does review sentiment correlate with star ratings? And from the research we've conducted so far, we found that there is a correlation between sentiment and star ratings. Specifically, the more positive the sentiment of the review, the higher the star rating. And by that token, the more negative the review, the less the star rating. So 1 star for negative reviews, 5 stars for positive reviews, that sort of thing. We also wanted to know what makes reviews helpful to other users. And for this one, reviews can help convince other users to view or buy a product. In this case, reviews want to convince users to read the book that's being reviewed. It can also help users to stay away from books that they won't like. We've also found that although there are some common words that can be used to associate positive or negative reviews, there is no structured format to the reviews themselves. One review could be written clearly, while another could be written using the bare minimum. This makes it difficult to find specific linguistic patterns in the review. So now that we know that review sentiment correlates with star ratings, we can begin using the data to now analyze reviews and predict the star rating of that review. From this, we can also see if there are patterns in reviews that other users find helpful.
By looking at the data quality between both the books dataset and the reviews dataset. So from table 1, you can see that in the books dataset, there are quite a few missing values in columns such as the description, authors, publisher, and ratings count. And then in the reviews dataset from table 2, you can see that there are less missing values in the columns such as ID, review score, and review time, but there are still significant missing values in the price column, user ID column, and profile name. And then from figure 1 for the rating distribution, a majority of the books have a 5-star rating, meaning that the data is definitely more skewed towards positive ratings. Quality insights, the mean rating is a 4.22, with the median being a 5.0 rating. So from figure 2, this box plot kind of shows how the ratings vary across the top 10 book categories. So most categories have ratings clustered around 4 or 5 stars with only a few low outliers, which tells us that ratings are consistently positive. Figure 3 looks at review length and helpfulness. The scatter plot shows a slight upward trend, so longer reviews tend to be rated as a bit more helpful, but the points are still pretty spread out. Table 3 confirms this with a weak positive correlation of 0.15. And then finally, figure 4 shows a clear positive relationship between sentiment and rating. So as reviews use more positive language, the rating tends to increase. So overall, the ratings are very positive, and longer reviews are only slightly more helpful, and the sentiment strongly aligns with the rating.
Technical progress. We've completed 2 major components already. First being the full text pre-processing pipeline, which is now implemented. That includes cleaning the review text, removing stop words, and applying lemmatization so that the data is standardized and ready for modeling. Also finished setting up feature extraction using bag of words and TF-IDF, which converts the text into numerical features the models can learn from. Right now, we still have 2 tasks in progress, but we've begun training the initial classifier models and we're currently running sentiment analysis on sample data to validate that the pre-processing pipeline is actually working correctly. So one of the biggest challenges we ran into was the size of the dataset. The CSV file was extremely large, and importing it into Google Colab took forever, literally up to 2 hours. So that approach obviously was not practical. So instead, we switched to Kaggle notebooks where the datasets were already available and could be loaded instantaneously. That made things much smoother. However, Kaggle has its own limitations. We couldn't install new libraries, so we had to rely only on what was already available. For example, downloading resources like NLTK stopwords had to be done manually inside the notebook. This also caused some inconvenience when moving the project back to Google Colab later, because certain setup steps weren't needed anymore and we had to rearrange and adjust new things. In terms of data cleaning, there weren't any major issues. That part was pretty straightforward. The bigger technical challenge was computational constraints. Google Colab ran out of RAM very quickly, especially with operations on large datasets. Some libraries like TextBlob were also extremely slow and caused long processing times. Switching to faster sentiment tools helped a lot to reduce the strain on memory and runtime overall. The next 1 to 2 weeks, our main focus will be completing the model training. We'll be running algorithms like logistic regression and naive Bayes, and we'll apply them to the full dataset rather than just like the smaller samples we've tested thus far. This will give us a much clearer picture on how the models will actually perform at scale. After that, in the following 2 weeks, we're planning to dive into deeper analysis. We want to explore how sentiment relates to things like review ratings and hopefulness, and to start generating visualizations, things like word clouds, distribution plots that help us better understand the patterns like in the text. And finally, our last phase involves evaluating and optimizing our models to get the best performance that we can. If time allows, we'd also like to experiment with a small recommendation system concept to show how, I guess, these insights could be used in like real application. So overall, this is a roadmap that we plan to follow and keep us on track.